sometimes it feels like we haven't moved that much further from Richard's car in networking.
Give me slide one then. Good morning, everybody. Well, it's no longer morning, but they always say Buenos Tardes all day long here in Spain. I'm going to talk about education, communication, and outreach, which I think is the first time that this is happening at IJEP. And I feel quite honored to give the first talk on education, communication, and outreach in a plenary closing session on outreach. The slides, they have something on. They all have this IPOC logo. IPOC stands for the International Particle Physics Outreach Group, which I'm happy to be co-chair together with Marge Bardeen, who I guess is somewhere here in the audience. And we're trying to get outreach a bit organized, emphasized in an international, global way. And we think that's important, as we just have seen in the previous speakers, getting to the next stages of building big machines globally. We do need global support for doing the next steps from now and the next decades. And basically, we always needed support for our endeavors, but that's getting more important. To get started, why basic research? Well, this is an often asked question, and we like to investigate the fundamentals of the universe. We like to understand who we are, what we are, why we are, where we are going, and we try to find answers to these questions. There's a deep belief, I think, among all of us, that this is a very nature of mankind. But it's also very nature of mankind to find answers, all kind of answers. If you have difficult questions that you can't find the true answer, you start doing philosophy, and maybe philosophy up in the sky, and we will never be grounded by experiments. And I think that's very important, that whatever we put up and invent, we're backgrounded by experiments. And for this, we invented tools and methods and ways to find objective answers to all our ideas, and objective answers to deep questions. And CERN is now having its 60th anniversary, and the logo, the motto of it is 60 years science for peace. And objective answers to deep questions is something that helps, that provides exactly that logo, 60 years science for peace. So we are all particle physicists. Why are we that after all? Well, we are curious people. We do want to understand more about the universe. And we think what we do is good for mankind. Otherwise, CERN would not have the motto, the logo, 60 years science for peace. And it's not just CERN. I think that's for all global projects we're going to have, for all international projects that we're going to do, for all big collaborations which are spanning across boundaries that usually we have within mankind, within cultures. But then we, as scientists, as physicists, we have to tell society that what we do is good for mankind. If we don't do that, we are just autists. We don't want to be autists, we have to tell. This gives a deep obligation to tell a story of what we do and why we are doing what we do. So we have to share, we have to inform with the public, yes, decision makers, important, and the science community. And I not just mean physicists with that, I mean also the chemist from your faculty, the mathematician or the biologist, geologist, and so on and so on. We have to have a global support, otherwise we will get into never-ending disputes. How to put resources, how to share resources, how to advance in not only particle physics, but in general in science. This is understood, and there are strategy reports on education, communication, and outreach. You see the European strategy report that came out at CERN last year in May, and it has a section, the wider impact of particle physics. And if you open that up, what you see is sharing the excitement of scientific discoveries with the public is part of our duty as researchers, just pinpointing what I just said. And don't go through the details, but the recommendation out of section N on the wider impact of particle physics is outreach and communication in particle physics should receive adequate funding and be recognized as a central component of a scientific activity. So, not just getting the next accelerator constructed, the R&D done, the detector built, the data analyzed, the paper written, published. Also, explaining to the world what we're doing, why we're doing, is a central component of a scientific activity. This way. There are also strategy reports from the US, not just Europeans that realized that. There's the SNOMAS report, has chapter 10, communication, education, and outreach. You can download it. The US particle physics community recognizes the critical importance of consistent and coherent communication, education, and outreach. And these efforts foster nationwide support for the field, develop the next generation of researchers, and help to develop a scientifically literate citizenry. I like that a lot. It's important that we have citizenry, scientific aware. Building an experiment, well, we're building experiments, that's what we do. We need to have an idea of what we want to measure. Usually we have some theory behind why we want to measure. We have to have a how to measure, which triggers a lot of R&D. We have just seen the program for the next detectors and the next accelerators, a huge R&D that needs to be done for tools and methods. And we have to build the hardware, we have to build the software, we have to take data, analyze the data, present the results, publish and discuss. But we have to educate, communicate, and reach out, share the why, the what, the how, and the excitement globally. I will quickly explain what education, communication, and outreach are, and I start with the education. We can educate formally and informally. Well, as a scientist, we are not teachers except at university level, but for undergrad, for the young kids, it's not us the teachers. So there we have the education is more informally what we do. We have to informally educate young teachers, young students and teachers. And think about the teachers, they are huge amplifiers. If we manage to engage the teachers in teaching modern physics, not just particularly particle physics, I think modern physics is a wide field, to their students we have a huge amplification. And out of the educated young kids will grow excitement, understanding, and support for basic research. And some of those will find their way to become particle physicists. Not all, it's not needed that all do that. But some will become supporters for those projects that allow advancing our quest in finding answers to fundamental questions. And just think about the big projects that have been presented by the previous two speakers in R&D for detectors, R&D for accelerators. And all will be citizens who vote. Don't forget them. Communication. The general public needs and wants to be informed. And communicators are good in transforming complex matter, for instance, the Higgs discovery, and the excitement of basic research, into headlines and into newspapers. That's what they do. And very often, the messages from communicators are often the first thing the public learns about our results. It's boiled down to the point in an easy language, and we often think too easy. They miss the point. It's wrong. Shivering when you read what they wrote. Sometimes very good. Sometimes very adequate. But think about it. Often it's the only thing an individual in the wide public will ever take note of what we do and why we do. Think about 2 years ago, ICEP 2012 at Melbourne, and you see here what was going on at CERN during that time. The Higgs discovery has been announced in a seminar and triggered some news coverage worldwide. And it was not the only one. We had a number of big events. Think about the startup of LHC in 2008. 100 million hits on the CERN webpage, 2,500 TV broadcasts, 6,000 press articles. And we continue. The Higgs discovery, another tsunami of news. Nobel Prize, end of last year, another tsunami of news. And all news in video broadcasts, national events, press releases, media, and so on. It's not an easy task. And what I want to show here that to get the message across, communicators and physicists have to work together, and it can be tedious and complicated. I would like you now to read along how this work together can look like. So, Atlas and, no, that's not what I want. Huh? Does it come? CERN has announced the discovery of, that was, always look who's writing. It's the physicist writing, Atlas and CMS collaborations, makes it more precise. The media guy, the discovery of the Higgs boson, or the God particle. Physicist doesn't like, hates it, scratches off. The media guy, physicist, that's not the Higgs boson. It's a new boson consistent with the properties of a standard model. The media guy doesn't know what a standard model means. The physicist, having seen an excess with a significance of 5 sigma, standard deviations, in the data collected and so on, blah, blah, blah. We know what we like to say, precise. Media guy doesn't like it all, scratches off. CERN discovers God particle. Okay. Physicists don't want PR. We don't want that we are seen as PR guys. We want to have accurate messages. The why, the what, and the how we have done things. Communicators hate lengthy, complicated text. They want something which is crisp and easy to understand. This we have to fall together. We have to work together. Communicators and physicists have to learn from each other how to do that. I think it's important. Otherwise, when you fall in the PR trap, we lose a lot of credibility. Here is where outreach comes into the game, because the news messages are out. The public has seen there is something. They have seen there is a Higgs. So some of those are curious. They want more, and in better detail. Now, science journalists and communicators can help. They do help. But somewhere, physicists have to come in, make sure what's being done is adequate and appropriate. And physicists, we have a duty and a deep obligation to participate in a dialogue with society. So, physicists are in charge of explaining more accurately, in bigger detail, what the communicators did communicate. Because don't forget, the public got hungry through this tsunami of news. And they are frightened because it did cost a few $1 billion. This is a complex task. And the concepts and the tools and the methods, how we did things, need to be made understandable to all those who want to know more. Needs a bit more time. It's complex. And we have to engage. We have to have the dialogue with society. And many, they are willing to listen. They're willing to learn. They're asking questions, deep questions. They need good answers. Understandable. When you do that, you will have an immediate direct reward. You engage with the public, and you will feel the excitement you get from the public. We want to do that credible. It has to be credible. For this, we need to have active physicists engaging, and it needs special skills. Otherwise, the language is too high. We talk above the heads of our audience. They get lost. They don't like us anymore. They will not vote for the next science-friendly government. And there is an article in www.sciencemag.org from May this year. Communication skills are among the top-ranked skills lacking in traditional science PhD programs. But the ability to explain complex scientific concepts to diverse audiences, not just to your peers, to a diverse audience, is a key asset inside and outside basic research. So it can always help acquiring skills in becoming a better communicator. So, another problem. Not all of the public want to know, and not everybody cares in advancing knowledge. Some ignore, some are even against advancing knowledge. Science has been cancelled because your parents prefer to believe in magic. Don't want. We should care about, because science literacy of a society is as important as literacy itself. We live in a modern world. We have developed tools and methods that are used in daily life. They shape our daily life and became an ingredient which can no longer be ignored. And if we fail keeping dialogue, we risk an unbridgeable gap in society between the scientifically literate and the scientifically illiterate. Cannot be for any good. So how do we reach out to the ignorant? That's a challenge. We cannot do that with scientific tools. We cannot do that in displaying the scientific methods even stronger. We have to explore different routes to share enthusiasm with a wider audience, which is orthogonal to what you usually think. And here we have been experiencing something which is nice and good. These are art projects. You see a lot of art projects outside in the exhibition hall, and I like them a lot. They involve more people that otherwise would never, ever listen or hear or want to know. But you reach to those from a different angle. This way you can share excitements, you can trigger reflections inside these peoples on the universe and science. And it's not just for the outside, it's also for us. We also like to see art. So it's a win-win situation. Then we need to organize education, communication, and outreach worldwide. We want to be global. We want to talk coherently, consistently. We have common goals. And there are a number of, there are labs, there are experiments, there's theory, there's measurements to be done. And there are groups who do that. Two groups I want to bring out who do communicate is the EPPCN, the European Particle Physics Communication Network, and Interactions.org. EPPCN is something that has been developed at CERN. I don't want to read you through all that. But these are communication officers from each member state. CERN has member states, and from every member state there's one science journalist, a professional, and they meet regularly, twice a year, discuss how to make communication coherent. Interactions.org is something similar among labs. So we have labs, we have member states, so it's understood, it's being built up. And IPOC, the International Particle Physics Outreach Group, is a network of physicists, formed since 1997. As EPOC, European first, we have transformed ourselves into IPOC International in just a few years back, with the aim to organize this globally. Web page, you can go there, you can see what we're doing. And the purpose is we want to strengthen sustainability and reproduction growth of outreach activities in particle physics. We want to raise standards in outreach. And we want to provide explanatory materials so everybody in the world can address to us and get help how to do outreach. Today, we are a network of 31 member states in IPOC. Well, this is not just the CERN members. We have every person in our group has a mandate from his home country via like ECFA, which has a member state behind itself, or we have a big physics society which says, yes, this person has the mandate of our country to do that. We do have big experiments who are internationally. We don't want to grow too big, but we want to be able to reach out. We have CERN and DAISY as members, and just very recently, Fermilab, a nice conversation with Nigel Lockyer. He wants to have somebody from Fermilab in our team. And if you have outreach projects to do, these are the people, you find them, contact them, and see what for outreach activities going on in your country and how you can profit from our network. And of course, new countries, labs, experiments engaged in all fields of particle physics are welcome to strengthen IPOC further. What did we do? You may have heard about the masterclasses in physics, which you can read about in detail in the CERN career. But look at this map. It's a world map, and all the green countries are where masterclasses have been going on, where young kids from schools have been trained for one day to be particle physicists. They have been analyzing LHC data. And just this spring, we had 10,000 students who went to 200 universities worldwide, to a university nearby, in 40 countries, and played with LHC data. Looking at what is a detector, looking what does particle tracks do inside a detector, looking at event displays, and classifying events into categories, filling up tables, building up histograms, learning something. This is a one-day program. And it works. These young kids, they get in, they come up with results, and they can compare what they've measured with real publications, which are actual, recent, new results. So we bring in the latest results from the LHC to the young kids. You can learn more about by going to this webpage. Another thing you may have heard is the beamline for schools. CERN is providing the T9 beamline from the PS to school kids. A huge program where we have announced that internationally, and IPOC was there, who was able to push that out, to provide contacts with our network to talk to schools. And we got participants from all these blue countries. We had 455 teams of school kids who said, yes, we want to use that T9 beamline at CERN. 300 even filed in a written proposal. And as we are in Spain, 35 teams from Spain. 16 teams got shortlisted, 2 from Spain. They got these shortlisted teams, they went through the SPSC committee, selected 2, 1 from Greek, 1 from the Netherlands, to form a collaboration and perform an experiment. This they will do this September. It worked because we could carry it out worldwide. If you have such a program and it only happens inside some member states, it would be the wrong message. You can carry it out. So this is all about sharing enthusiasm to very young. So this is something from the Prince of Asturias Foundation. They had a competition, and this is a 7-year-old girl. She explains how her balloon gains mass when being pushed through paper snippets. Very enthusiastically. Even if she doesn't understand the math, she knows how to play with balloons, but gets something that this must be important when people make so much fuss out about. Or this is one of the teams. I won't show the movie for this, I don't have time. Or at CERN, we have open days. 70,000 visitors came from young to old, and even important people getting in touch. We had 2 parallel sessions at this IJEP meeting on Thursday and Friday. I don't go into it now, but I invite you to look at the slides. They may be inspiring for you. They may trigger you to initiate some activity in your own town, and you may want to get in contact with IPOC. Summary: consistent and coherent communication, education, and outreach are of critical importance to support our field. To investigate further in basic research, as we think that's important. To develop the next generation of researchers, and help developing a scientifically literate society. However, communication outreach requires special skills. The communicators and active particle physicists have to learn from each other how to do that best. But it's a good investment. Communication skills are useful for physicists inside and outside an academic career. And dedicated networks and organizations have come in existence in support of global and coherent education, communication, and outreach activities. Those need to be supported, those need to be strengthened further. So, a few recommendations. If you're a young physicist, engage a small fraction of your time. A small fraction. Don't become fully professionals in that. You also want research to do. You also want to push your academic career. But engage a small fraction of your time in education, communication, and outreach. If you're a group leader, engage a small fraction of your time in education, communication, and outreach. But support your group members who are active doing that. But not everybody needs to do that, but you have to have a few. That's good. If you're hiring a new postdoc or a faculty member, make sure that the person you will hire has good communication skills. You want that usually. In case this person has a track record in outreach activities, even better. And with this, thank you. Thank you for your attention.
Thanks, Hans-Peter. Are there questions? Middle there.
You gave this example with that animation of how exchanges with journalists can go wrong. I think that we're putting too much blame on the journalists. If we just look at the messages that we as scientists give out, I find myself very embarrassed by being represented by some of the press releases that come out of CERN, for example. We've been reading recently that physicists don't know whether antimatter is attracted or repelled by gravity. We've been reading that by measuring the anti-hydrogen mass, we've come one step closer to understanding where antimatter has gone in the universe. These are plain lies. And these are lies that maybe the public can buy, but our colleagues in astrophysics, in solid-state physics, very clearly recognize. So I think that we should all be engaged in communication and in outreach. But I think that we really need to review very deeply the policy, what it is that we want to communicate, up to which point we really want to go out and turn every single event of our scientific life into a public event. Because even though the record of the past few years has been very positive in terms of engaging and exciting the public, there is no question about the numbers you gave. I fear that on the long term, if we exaggerate, this could fall back on us in different ways.
I fully agree. I was raising that there is a PR trap we could fall in, and we should not allow for falling into a PR trap of being seen as thin, shallow, or just there for making news messages in newspapers. That's why I say there must be physicists who can convey credibility in our field, who have to engage in outreach activities. We have to be there to answer the questions rightfully. We have to educate what we're doing, and I think this masterclass program, or also this BeamLab for School program, are wonderful tools, ways, methods in explaining in detail how we are doing and what we are doing, and also the why we are doing the research we are doing. We also have to talk to our colleagues in other areas, as you mentioned. That's what I meant. The outreach is also to the scientific community. And I said it's not just the physicist. But here the language has to be correct, adapted. These are points that we can discuss in our global network. That's why I was building up the world map with all the organizations and engaged in communication and outreach activities. We have to work together in order to find the level, the right level. And in there we have to have physicists who exactly come up with the concern that you brought up. What is the right level? How many PR messages can we afford? Too little is not good, too many is not good. So,
I think that's perhaps a good place to stop. So let's thank Hans-Peter, and also, I guess, congratulations to the outreach group for the growth in this rather professional area, and with the two parallel sessions, it really shows that things are moving. And thanks to all the other speakers for the morning. There were some very good presentations.